Good evening. Tonight we're going to do 6.3 and we're going to start on page 310. So please turn to page 310. All right, problem 1. You can use the distributive property in reverse. Consider the expression 7 times 26 plus 7 times 14. Since both 26 and 14 are being multiplied by the number 7, the distributive property says you can add the multiplicants together first and then multiply their sum by 7 just once. So they're going to grab the 26 and the 14 here and here and add them together. So 26 plus 14 is 40. So we're going to do 7 times 40. So then we would have 7 times 40. 7 times 4 is 28. Add a 0 to 80. The number 7 is a common factor of both 726 and 714. So to factor an expression means to rewrite the expression as a product of factors, and then a common factor is a number that goes in, and when the word common happens, it's when it's in both. All right, so now it wants us to factor each expression using a distributive property. So number 1, we have 4 times 33 minus 4 times 28. So in both of those, the number that's in common is the 4. So we could do 4 minus 4 times 33 minus 28. 33 minus 28 is 5. 4 times 5 is 20. By doing this, we saved ourselves a lot of work instead of doing 4 times 33 minus 4 times 28. Let's try B. And it says to factor each one. So let's look at B. All right, so there's a 16 in both. So I pull the 16 to the side, and then I'll have 17. And then this one we're adding, plus 13. And all it says is to factor. It doesn't say to solve. I know I solved this one because I could do it in my head. Let's go one step further, but I won't make us solve this one. 17 plus 13 is 30, so we would have 16 times 30. All right, the distributive property can also be used in reverse to factor algebraic expressions. For example, the expression 3x plus 15 can be written as, and you take out the 3x plus 3 times 5, or 3x plus 5. The factor 3 is the greatest, and we learned about common factor earlier, common factor to both terms. The greatest common factor, known as the GCF, and this should look familiar to most of us, is the largest factor that 2 or more numbers or terms have in common. All right, consider the expression 12x plus 42. The greatest common factor of 12x and 42 is 6. So I can take 12 divided by 6, which is 2, and 42 divided by 6 is 7. So therefore, you can rewrite the expression as 6 times the quantity of 2x plus 7. It is important to pay attention to negative numbers. When factoring an expression... Sorry about that. It is important to pay attention to negative numbers. When factoring an expression that contains a negative leading coefficient or first term, it is preferred to factor out the negative sign. A coefficient, lots of new vocabulary tonight, is the number that is multiplied by a variable in an algebraic expression. All right, now we're on page 311. So, look at the expression, negative 2x plus 8. You can think about the greatest common factor as being the coefficient of negative 2, so the outside portion here. Well, negative 2 goes into negative 2x, so negative 2x, and then negative 2 goes into 8. Well, remember, positive times a positive is a positive, a negative times a negative is a positive, and then negative times positive is a negative. So if I pull out a -2, I know that I have to multiply by a negative number because negative times negative is a positive, and 8 is positive, so then it is -4. And then when I rewrite it here to combine, I would do -2 times the quantity of x minus 4. So let's rewrite and practice this, factoring out the GCF. So what's the biggest number that goes into 7 and 14? It would be 7. 7 times x is 7x. 7 times what is 14? 2. And that would be letter A. I want you to try A. Well, we just did A. B, C, D, E, F, G, H, and I. Go, 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 and press play when you are finished. All right, and here on my answer key, it even shows you both parts, the 7, the x, the 7, and the 2, and then combines it. So make sure you have the same answers as I do for A, B, C, D, E, F, G, H, and I. So just freeze the screen or whatever you need to do to check those and make sure you understand what's going on so that you have the work done in your book. All right, we're going to now be on page 312. So let's look at problem 2, using the distributive properties to simplify. So far, the distributive properties have provided ways to rewrite given algebraic expressions in equivalent forms. You can also use the distributive properties to simplify algebraic expressions. Consider this one, 5x plus 11x. What factors do the terms have in common? Well, 5 and 11 are prime. Well, x, they both have an x. So if I take out an x, I would write x times the quantity of 5 plus 11. All right, and I rewrote that here for number 2. So that's number 2's answer. So when it says what factors did the terms have in common, you can simply say they have the x in common. And I already simplified it, so this is actually the answer to 3. So sorry, I did big steps fast. We could have written 5 times x plus 11 times x. We combine the 11 and 5, pull out the x, number 3. There we go. Sorry, that was confusing. I apologize. But basically, you look and see what's in common. Well, 5 and 11 are prime. That doesn't work. The x is in common. All right. The terms 5x and 11x are called like terms. Like terms, meaning that their variable portions are the same. When you add 5x and 11x together, you are combining like terms. So the final thing I could do to simplify my expression is write 16 x. 5 plus 11 is 16, so 16x. Alrighty. 4. Simplify each expression by combining like terms. Well, I have a and b, so I'm going to pull out the a and the b. And then I'm multiplying by 5 and 22. Well, I have 5 of these and 22 of these. So should we do 5 times 22? Or should we do 5 plus 22? Go ahead and think about that for a second. All right, we should add them because the sign is adding, so 27ab. Then number 4, what's in common? An x squared is in common, so I pull out the x squared. 32 minus 44. I have $32 and I spend 44. I now owe my grandma 12 bucks, so I'm $12 in the hole, so I would have negative 12 times x squared. All right, simplify each expression by combining like terms. Same thing here. And then it says, if the expression is already simplified, state how you know. Important part, make sure you do that. Try A and B now. Go, go, go. All right, go ahead and check and make sure you're on track for A and B. For number 5, 15x and negative 47y, and then finish the rest of the letters. So you did A, B, do C, D, E, F, G. How many are there? Let's see. H. So finish the rest of these, and we can compare and share with our neighbors tomorrow in class. Press play when you're ready. All right, more factoring and evaluating. So we have A here, we have negative 24x plus 16y. This has an x, this has a y, so that isn't in common, 24 and 16. Well, what is in common of those? A 4, and since this is negative, let's pull out a negative 4. So I'm going to do negative 4 times 6x plus negative 4 times what is 16? Well, a negative times a negative is a positive, so I'm going to need a negative 4y there. Plus a negative is the same thing as subtraction, so you could have skipped this step, or you can write it in 2 steps. So negative 4, 6x minus 4y. Then you notice, Miss Roan, that both of these numbers are even, 6 and 4. So did I take out the greatest common factor, yes or no? What do we think? I think that I did not. I could have taken out an 8. So let's do that instead. So negative 8 times the quantity of 3x plus times a negative 8 times negative 2. So let's go ahead and write minus, I'm skipping that middle step there, 2y. So if you do this and you get even numbers in here, you know that you did not take the GCF. So I kind of wanted to show you that and goof up. Go ahead and try B, C, D, and E, and press play when you're done. All right, go ahead and check your B, your C, your D, and your E. Number 2 here says evaluate each expression for the given value. Then factor the expression and evaluate the factored expression for the given value. So first you factor, so you have negative 4x plus 16 for x equals 2.5. So I put 2.5 where the x is. So I plug in, here's my x, I plug in. So 4 times 2 is 8, and 4 times a half is 2 wholes, so that would be 10. The other way I could do that is around the world. 2 times 2 is 4, 4 plus 1 is 5, so that's 5 over 2, and I have negative 4 over 1. Cross simplify, negative 2, 2 becomes a 1. 2 times 5 is 10, and don't forget your negative sign, over 1 times 1, which is 1, so still negative 10. So there's a couple ways to do that if you're confused on that. And that's how the book did it here. So they get negative 10 plus our 16. I have $16 and I spend 10. How much money do I have left over? I have 6 left over. And then it says factor the expression and evaluate the expression here. So if you were to factor this first, so now we're doing part 2 right here. So you could see what goes into both, a negative 4, so I take out a negative 4. See how they wrote this as plus a negative 4? You could also just write it as minus 4, and then you get to this math, and they should get the same answer for step 1. That way we got 6, and this way we get 6. All right, go ahead and do B on your own, and when you're done, press play and check your work. All right, you should have gotten this, 28 9/10. Make sure you understand the 2 different ways. This first way is evaluating for the expression because I plugged in for x and just went for it. The second way is where I combine like terms, find that greatest common factor, and then plug in second because you didn't plug in right here. All right, and to finish this up, just a little more practice. For homework, I want you to do page 314 And you don't have to do it all. I want you to do A, C, and E. So every other one there. So the word ace, do those 3. And then 2 has A and B. B's on the next page. You don't have to do B. Do A here. So on page 314 for homework, do A, C, E. And then number 2, do A. And we'll see you tomorrow. Have a great night, and thank you for your time. And that ends 6.3.